Hi, this is Cheryl Abrigo with USF Tech Transfer Office. Today we are visiting with Dr. Cliff Merz, Senior Research Faculty Ocean Engineer here in the School of Marine Science. Welcome. Thank you for joining us today, Dr. Merz.
Thank you for the opportunity. It's my
Absolutely.
pleasure.
So you are also in charge of the Coastal Ocean Monitoring and Prediction System.
Yes, that is a program that we have on the West Florida shelf. It's been around for over 20 years, and it constitutes a number of monitoring assets, offshore weather buoys, coastal stations, high-frequency radar sites, and then also a lot of support staff in order to keep those systems running. The data we monitor, it is collected 24/7, telemetered back to this facility, distributed to various agencies, and then we also use it for the very extensive modeling program that we have here. Dr. Yonggang Louis has that, runs those on the modeling, and it's very extensive. Results are part of the spaghetti models that you see, especially when things are coming into the Gulf of Mexico.
That was gonna be the next question. Did these interact with the hurricanes and all those wonderful visitors that we have?
Yes. The data is collected. It's hard to keep them operating, at times, but it's a very good and worthwhile endeavor.
Awesome. So there's also aside from that, you have some marine science technologies that you're passionate about.
Yeah, when I was first considering disciplines, I'm from Wisconsin originally, and I was involved in engineering, but I had that draw to the ocean. And so a number of years ago, I came down, I got a degree from Florida Atlantic University in ocean engineering, and I've been continually interested in various things engineering related in the ocean, primarily ocean energy and marine materials. And so my research, my PhD was looking at salinity gradient, differences in salinity gradients, trying to use that to generate electricity and power from it. And the key to these salinity gradient power type devices is the membrane. So that's the separating device that separates the salinities of two different amounts. And so I've been doing research off and on, trying to develop new membranes. We've got a few patent applications in, and a patent that we have, looking at different materials that were used for those membranes. And one of those membranes that we're looking at right now uses marine bio-waste. There's a material called chitin, which is found in the exoskeletons of different marine creatures like crabs and lobsters and shrimp shells and such. So we're using that material to generate and produce a membrane. And then that membrane we're using to look for different things on how that membrane may allow for the passage of water and different gases.
Very interesting.
Yeah.
This is cool. So when you came down here to go to school, you never went back up north?
I went up for 2 years to Connecticut to work for a submarine manufacturer. And it was pretty good work, but it wasn't quite the same that I was looking for. I came back here. I worked in different parts of Florida as a Navy contractor, a few other things. And then the opportunity came here for the comps program.
Very good.
And so I came here, and I've been here ever since, over 25 years.
Yes, we've been very lucky. We've been very lucky, and we've known you for
very
quite
much.
a while.
Yes, yes.
So what would be your ultimate goal for this new technology, well, not the technology that you have going forward?
Well, there's a couple of different applications. Like I said, we can look at it for passing both liquids and gases.
Hmm.
The liquids would be maybe for things like the salinity gradient power, where we'd have an area of let's say fresh water versus highly salty water.
Okay.
The ions move across, then you
Mhm.
can generate electricity from. Another application is looking at gas movement across the membranes, whether it's CO2 or water vapor or things like that. So presently I'm preparing an STTR
Okay.
in conjunction with Oak Ridge National Labs,
Okay.
and
Mhm.
then also various researchers over in the engineering department at
Okay.
USF.
Mhm.
And we're looking to put together hopefully a successful proposal,
Mhm.
at least for phase 1 and for phase 2, to further develop these membranes, in this case for gases, for looking at dehumidification,
Okay.
removal of water vapor.
Right.
But then those membranes, I think, will still be able to be used for the salinity gradient power aspects that I'm also interested in.
Awesome.
Mhm.
This has been so fascinating to learn more about. I know we've seen things over the years, but
Right.
get this in detail.
Well,
That's very
yeah, I
exciting.
thought I would, in case those might
Okay.
want to look at it, but this is an example,
Oh, this is very interesting.
yeah, of what a little piece of the membrane is that
Very
you can make. I mean, it looks like a
And it's
little piece of plastic.
it does, and
Yeah.
it just
Yeah, and you separate that, you put it into a test cell, and you have liquid on one side and liquid on another, and it passes through the membrane. Water will move through on one side, ions will move through on the other side, depending upon the gradient of the salinity it
Okay.
provides for the driving force to move it.
this is really cool.
So sometimes people don't actually, it's kind of like a piece of saran wrap.
It is.
Just
Uh-huh.
a more
Wow.
solid, and depending upon the formulations and depending upon the compositions that you use, you can make these thinner or different forms.
Okay.
This is basically a flat sheet, but you
Mhm.
can make it into tubes and all kinds of different shapes depending on what you're looking at.
Oh, I'm glad you shared that with us. That's fascinating.
Well, thank you.
Well, thank you. Thank you for joining us today. It has been very interesting. Thank you for joining us, and we'll see you on our next edition.
It's my pleasure, and thank you for the opportunity. And nice to meet you and see you again.
See you again, too.
Yes, yes.